Hello, my name is Brian Toe, and in Lab 2 we did an experiment on the motion of a falling object. This lab had us observing the motion of an object that fell downwards in a straight line, in this case a dry erase marker. The experiment measured the position of this object over time and compared that experimental data to a computational model accounting for gravity only, as well as a computational model accounting for gravity and drag. The first model used Newton's second law to account for the position of the object over time, with gravity being the unbalanced force that affected this position. And so F net equals negative mg in this case. With this F net in mind, a closed grip model was constructed that accounted for gravity being this only unbalanced force. And so this position versus time graph was modeled as a result of this. And it shows a curved position versus time graph as the object fell. And in this case, there was no terminal velocity. In Newton's second law, gravity and drag can also be accounted for, and this was done in the second model to predict this position with this new F net of negative mg minus bv squared, b being the proportional constant of drag, and bv squared being the overall drag force. This resulted in a model that had another curved position versus time graph where the object fell, and in this case reached a terminal velocity that was towards negative as the object reached about half a second. And so we were able to compare these different models to the actual experimental data of the falling object. And in this case, the gravity and drag model was closer to the experimental data, as it showed a similar terminal velocity and similar position as it reached this half second mark. And both the positions were about negative 1.1 in both of those in both model 2, the gravity and drag model, and the experimental data. And so that was a better fit. And this is really the answer to the what does it mean question, as model 2 with drag and gravity was a better fit when compared to the experimental data because of this terminal velocity as the position versus time graph leveled off in slope towards that aforementioned 1.1 meter mark, or the half a second time mark. And for the what if question of if the object was initially thrown downwards instead of just dropped, the object would slow down to the same terminal velocity due to drag being proportional to the velocity of the object. And so it would eventually reach the same terminal velocity in the end, whether it was dropped from rest or thrown downwards. Overall, Lab 2 taught a great many things about the velocity of an object that is going downwards.